All right. Good morning, class. Hope you're having a good day so far. We're just kind of got into it here. But anyway, so I'll date the lecture, I guess, by the following comment. Campus was closed yesterday, so I hope you had this. You were successful in skating wherever you went. So there wasn't any ice on the road this morning. It didn't seem to me like. So anyway, it's great to be here today. We will kind of wrap up Unit 1 today, a week from Saturday. So I probably should have scheduled the first exam earlier than I did. I'm just kind of learning the pace on this class this semester. So at any rate, that's okay, but we will talk a little bit about, actually may even today introduce a little bit of Chapter 6, but Chapter 6 will be in Unit 2, okay? But this gives you a chance to catch up, and I watch your homework. I kind of keep my finger on the pulse with everybody's progress. So on MindTap there, I can just pull up everybody's scores and see where you are. So I think it's probably good we have a little extra time on this first exam. I kind of built that in. I mean, with 3 units and 15 weeks a class before finals, I can divide 15 by 3 and get 5 weeks a unit. And so, but it's at the end of your 6th week, you'll have your first exam. So that'll be next week. So, but again, I was a little deliberate in doing that. I weighed that out at the beginning of the semester so that you'd have, so that, you know, in case what happened should happen. And what happened was some of us, including your professor here, was a little slow in getting used to Cengage. So, but at any rate, I think we're up and going with that. It took me about a week to kind of figure some things out there myself. So anyway, be that as it may, we're going to wrap up Chapter 5 today and so forth. Got a couple other things in mind here for today. So. Interesting remark here in your textbook on page 102. I marked it here. It says even a parrot can become an economist simply by learning to say supply and demand. So there's a lot of people think that's all there is to economics. At some level, I guess perhaps there is. We're going to add to this supply and demand model as we go forward. It says that's an old joke, but these last 2 chapters should have convinced you that there's much truth to it. The tools of supply and demand are useful for analyzing the events and policies that shape the economy. You are now well on your way to becoming an economist, or at least a well-educated parrot. So at any rate, I thought that was a little humorous, and I always appreciate it when scholars in any field engage in a little self-deprecating humor. There's plenty of that to use in the field of economics. Economists, unfortunately, have to retract statements they make and so forth. So, as Harry Truman once said, give me a one-armed economist because there's too many of them that say, well, on the other hand, right? So, these models are abstractions. We looked at supply and demand. They're kind of a simplified description of how the world works. But, sometimes in those simplifying assumptions, we miss things, and we simplify things too far. Albert Einstein once said, make everything as simple as possible, but not simpler. Okay, that's good advice, right? So, we try to describe the world in simple terms, but sometimes we go too far. But at any rate, you got to start somewhere, and so we'll be refining this model of supply and demand really in Chapter 6. But the topic of Chapter 5 is elasticities, and so you should have a notion of what elasticity is, kind of the general concept in economics. And so I found, last time I couldn't find this piece of paper I had written the time before. So I found it buried on top of my desk. So So two lectures ago, I wrote this on a sheet of paper here to define some elasticities here. So we had, let's see, we have price elasticity of demand. It's percent change in quantity demanded over the percent change in price. Of course, you could equivalently or analogously have price elasticity of supply. Okay, the same sort of thing. So the word order is significant. I mentioned this last time. Whether it's income elasticity of demand, I think we used XED as well as E sub D. No, this is not, sorry, income, IED, that's what it was. Sorry about that. Income elasticity of demand, cross-price elasticity or cross-elasticity of demand. That first letter, okay, these are all acronyms here, and that first letter references something that's going to go in the denominator, okay? That's basically a cause, and the effect is designated by the last letter. Okay, all these are elasticities. Okay, so you got E in the middle, but just this is important to be precise with the language. Okay, when someone says, "Oh, the elasticity of tomatoes is such and such," what in the world do they mean? Now, a lot of times we think in terms of price elasticity of demand, but it could be income elasticity or one of the cross elasticities. So you need to be precise with the language again, with the labels you put on these. So this is in the denominator, like here we would have income in the denominator, IED, and cross elasticity of demand. Well, the idea here is the price of the other object, okay, or the other good, rather. So we could look again at the cross elasticity of demand between potatoes and I guess maybe, let's say oranges and apples. I like that better. So at any rate, the idea, especially with with income and price elasticity of demand, the first letter refers to the variable that's in the denominator, and then the last letter here, demand, of course, is what we're talking about in the numerator. So if we had price elasticity of supply, it's going to look like this, except PES would have change in quantity supplied in the numerator. So try to get used to this notation here. And I thought we would kind of wrap up chapter 5 here today by looking at a few more of these end of chapter problems we were looking at last time, and questions for review actually that are in your text on page 108, beginning on page 108. So these are all good. I've already begun working on your exam or show-off opportunity, if you will, for next time, for a week from now. I guess, by the way, in this class, I've again made your exam or show-off again. Keep slipping in that, but for Saturday. So it'll be open for 24 hours. I could be persuaded in extending that into Sunday. I don't really like to have you do anything on Sunday. Yes, Riley.
Will that be on Cengage? Mine's have one on Blackboard.
It will be on Cengage. Okay, you'll access it through Blackboard, but it will be on Cengage. At least the way I have it set up presently. I'm kind of testing it a little bit, but it should be on Cengage. And kind of the way I do kind of what I call stratified sampling from the test bank a little bit on that. Not all of it. There'll be questions I've designed, but then there'll be a little sampling from the test bank that goes with this text, kind of in a stratified way. So I set some parameters and level of difficulty and so forth. Generally like to hit kind of middle of the road, not the real difficult problems, but I look at problems that are similar to what we're doing in class, okay? And so you'll see some of this stuff that we're doing today on the exam, okay? So, and that we have done. So remember last time, for instance, we calculated, we've done some calculation of elasticities off of a linear demand curve. We calculated change in total revenue and some of these concepts, very important concepts about how total revenue is related to price elasticity of demand and supply, okay? And so if you have changes in price say for a price, when I say price inelastic good, that means it's price elasticity of demand is between 0 and 1. If you have a price increase, what does that do to total revenue and so forth? Some of those concepts we were looking at between total revenue, relationships between total revenue and price and so forth. Be sure and drill on those, okay? Be sure and drill on that stuff. I'll have more to say about that next week. We'll do a little bit of a review again. We'll summarize these chapters before we get to the test. These are all good things here. Be sure you go through these. I've looked through all these. You know, how about this number 8? If a fixed quantity of a good is available, can y'all see that? And no more can be made, what is the price elasticity of supply? Okay, so what do you think? Is there price elasticity of supply? If you can't make any more, it's a perfectly inelastic supply. Actually, they gave you a picture of some of these back here on page 99. Here's a perfectly elastic supply. Price elasticity of I said perfectly elastic, perfectly inelastic is what I meant to say. PES here is 0, okay? So make sure you kind of understand some of these concepts here. So the deal here is, just my camera a little bit here, the quantity supplied is completely unresponsive to a change in price and so forth. So, okay, hopefully, you know, the idea of elasticity, again, is becoming intuitive to us. Something is inelastic if you can't change, you know, you can't change the length of it or what have you. You know, rubber band's very elastic, but a steel rod is inelastic. Same thing here. The quantity supplied is just sitting there, okay? So whatever this thing is, okay, that's supplied. Some items that require a lot of, for them to be produced, requires a significant fixed cost. Okay, in other words, I mentioned petroleum refineries and so forth, the distillates that they produce from a barrel of oil, you know, those proportions are somewhat fixed. It takes a lot of effort to go in there and retool things, okay, reset things and so forth. But, you know, the quantity of gold in the world is largely, it may not look like this, it may look a little more like this. But, you know, there's not a fixed amount of gold in the world, but it doesn't really change much from day to day, certainly. Okay, they say, and I guess this is true, but if you took all the gold that's been discovered since mankind was in the Garden of Eden, the amount of gold that has been discovered since then could fit in 2.5 Olympic swimming pools, something like that. Okay, certainly it's not more than 3 Olympic swimming pools. To me, that's an astounding fact. Okay, because it's a big world, and you can take all the bullion in the world, you take all the jewelry in the world, melt it down, and there's only so much gold. Okay, so it's fairly inelastic. It's a fixed supply and so forth. So, you know, this would characterize a lot of things. During COVID, you know, some of the things that we wanted access to, what was it, N95 mask or so forth, for a while, it's like there were only so many of these things, right? And, yeah, do what? Toilet paper, okay, yeah, right. You'd have thought, I mean, and demand as well was like, you know, everybody had to have a bunch of that. But yeah, the supply was like, where is it? You go to the grocery store, it's not there, right? And so very inelastic supply. Okay, all right, let's look at some of the problems then that follow these. These are, again, all of these questions for review are good, okay, right here. But again, on page 109, I know it looks like we're reading through a book on a soda straw. Through a soda straw. Okay. But let's look at some of these problems. I've photocopied these just for a little practice here, and I may give you a chance to practice a little today as well. But look at with me, okay, just number 1 here, just a second. Let's do some, whoa. For each of the following pairs of goods, which good would you expect to have a more elastic demand and why, okay? So these are good exam kind of questions, okay? It tests whether or not we understand the concepts, the basic concepts. So which would be the more elastic demand? Required textbooks or mystery novels? Which would be the most elastic? If we're talking about price elasticity of demand, what do you think, class? Which would be the most elastic as far as demand? Not supply, but demand.
Novels.
Okay, novels, right? I mean, can't you live without a novel? You can kind of a luxury item, right? It's kind of optional. So if you start thinking about optional things and so forth, they're more elastic. So if the price goes up a little bit, you say, hey, I don't need this. Now your textbooks, hopefully, you got to have a textbook, right? I'm big on that. I'm really believe in textbooks, using that. Not everybody does, but to do economics, you got to, at least in some form, have access to that textbook. Okay, so the most elastic here is mystery novels, okay? That would be the one that's most elastic. Billie Eilish, am I saying that right? Eilish, okay. Boy, I'm a pop culture dummy. But at any rate, Billie Eilish, okay, recordings of pop music, recordings or pop music recordings in general, okay? Billie Eilish recordings or pop music, which would be the most elastic, class? What do you think? Now remember, we talked a little bit about the ability to substitute an item with another item is somewhat a function of how broad the category is that we're discussing. So I take it Billie Eilish is a pop music star, but not the only one, right? And so if you like pop music, you could switch from Billie Eilish to another pop music, right? But if you're really hung up on pop music, that's what you got to have. So the one that has the most substitutes would be Billie Eilish, right? So if a good has a lot of substitutes, then it's very elastic. You can switch back and forth from it. Okay, so the most elastic here is Billie Eilish. That's the one that's most elastic. Okay, it's a subcategory of pop music. So at any rate, you got that. Subway rides during the first 6 months or subway rides during the next 5 years. Okay, so if you're riding the subway. Now think again about substitutability here and so forth. Now which one of these would be the most elastic, do you think? Subway rides, so if you had to buy a ticket, for 6 months in advance and then for 5 years in advance, what do you think? Which one would be the most elastic? Demand elastic. Okay, well, I appreciate that, but where's my little buzzer? It goes, you're a good sport, okay? You're a good sport. How about 5 years? The reason is, we got into this with gasoline, talking about, last time we talked about the, if there's a spike in the price of gasoline, how do consumers respond? Well, in the short run, they can't respond, maybe. They're locked into a commuting pattern or what have you. So, but in the long term, they'll find another way. So the idea here is that subway rides during the next 6 months, if the price goes up on subway tickets for some reason, and you commute in town, you're still going to buy that for 6 months maybe. You say, well, I'm going to figure this out in 6 months, but I got to get to work tomorrow in the next week. Okay, so 5 years, this would be the most elastic, okay? Because it's easier to substitute away from subway tickets if you have 5 years to do that as opposed to 6 months. Root beer or water, class, which one of these would be the most demand elastic? Root beer or water? One of these you got to have, right? You got to have it. You got to have water, so your demand is inelastic. It's not going to change, okay? So, I try to drink 8 glasses of water a day, and I'm going to do that even if the price triples tonight, I'm going to still drink water, okay? I'm going to drink about the same amount. Now, root beer, okay, if the price of root beer goes up, I want to start drinking Coke or lemonade, something else, okay? So again, you're talking, it's kind of like part B here. This is a subcategory of this. So this has more substitutes than this. So the more substitutes you have, the more elastic. The longer time you have to do the substitution, the more elastic, okay, the demand would be, and so forth. The more, or I'd say the less essential an item is, the more elastic it is. So hopefully you're building some intuition on some of this, okay? Building a little intuition. Look at number 2 here, maybe. I don't think we did 2 last time, did we? Okay, so suppose that business travelers and vacationers have the following demand for airline tickets from Chicago to Miami. I can't read this. I flew out of Chicago with my kids once, and we got dropped off in Goose Bay, Canada. That's a long story. So we were going to go to Heathrow. At any rate, airplane had trouble. So, but from Chicago to Miami. So here's a demand schedule. Here's price and quantity. Demand schedule for 2 different classes, okay, of travelers. As the price of tickets increases from $200 to $250, what's the price elasticity of demand for business travelers and for vacationers? Use the midpoint rule. Okay, so you know, we could just do one of these. We don't have to do them both, I guess, to make sure we got it. But maybe to do a comparison. So from 200 to 250, okay? You know, as far as business goes, BIZ, you know, the demand looks kind of like this. All right? We're saying that at a price of 200, there's 2,000 tickets and demanded, and at a higher price of 250. Again, this is the price axis. At 250, there's 1,900. Okay, so this is, sorry about that. This is for business travelers. So should be able to find E sub D. E sub D is the percent change in quantity demanded divided by the percent change in price. It said to use the midpoint rule, okay? So percent change in quantity demanded. So that would be 2,000. Just the difference here is all we care about, really. We know they're going to go in opposite direction. So 2,000 minus 1,900 over the midpoint sounds like 1,950. Okay, that's the change in quantity demanded. Change in price is 250 or 200. It doesn't matter the order because divided by 225. So you have a fraction on top, you got a fraction on the bottom. You can do those separately if you want. I think the numerator is maybe 0.05. Denominator is 0.22. And so this would be 0.23. Okay, so it's fairly inelastic, right? Now, let's compare this. Let's compare this with E sub D for vacationers, okay?
Say with the 250 minus 200, the order doesn't matter.
Yeah, it doesn't for our calculation. It certainly does on the sign here. But remember, all we care about, we always know this is a negative, okay? We know these two are in opposite directions. So it's really the absolute value of the difference over the midpoint. Of course, it'll matter. So, you know, if I subtracted in the same order, notice I had 2,000 first here, so I should have had 200 here first, right? Which should have made this negative. But the thing is, to calculate ED, we know that you're always going to have opposite signs in the numerator and denominator. All we really care about is that between 0 is the absolute value between 0 and 1 or greater than 1.
Got it.
Okay. So since this is between 0 and 1, it's price inelastic. Now for vacationers, let's look at that for a second. Vacationers, same price as 200 and 250. So I don't know, you know, this kind of helps sometimes to draw a rough picture. You know, I didn't really measure anything out there, but for 200, at $200 there's 800 and then there's 600. So I'll pull this off here, okay, this last column. So E sub D is the percent change in quantity demanded again over the percent change in price. And percent change in quantity demanded, that's Q here, Q axis. This is 800 minus 600 over the midpoint, which is 700, right? And the percent change in the price is 250 minus 200 over the midpoint, 225. Now, both of those really make them percents. You have to multiply by 100, but then the hundreds would cancel. So at any rate, if you do this calculation here, I think you get 1.32. Okay, so you can check that out. 1.32. So does this make sense? What we're saying here is that if you compare business travelers with vacationers, vacationers are more demand elastic. Price elasticity of demand is much higher. Well, yeah, right? Because if you're a business traveler, you got a meeting somewhere you got to be at. Okay, so you got to travel on that. Vacationers, you say, well, you know, I could go at a different time or what have you. I can catch the next flight if I have to. We've all been in the airport where people have been bribed to do that sort of thing. Okay, so that's number 2. I'm going to mark some of these off as we do them. 1, 2. I want to make sure we get to certain ones here, so we might just jump around. Let's do number 3. Okay, it's the next one anyway. Number 3. Okay, so suppose the price elasticity of demand for heating oil is 0.2 in the short run and 0.7 in the long run. If the price of heating oil rises from $1.80 to $2.20 a gallon, what happens to the quantity of heating oil demanded in the short run? Okay, all right, so obviously here we care about, you know, the price elasticity of demand. So you have a short run. They tell you have a short run price elasticity of demand, you have a long run. Now notice, so the good is more elastic in the long run than in the short run, price elastic. Why is that? Demanders have time to substitute, right? Now, you say, what's short run and long run? In economics, we'll give them a little more precision to those terms. We'll define those a little more stringently later. You can think of short run as being less than a year and long run being more than a year or something like that. But for now, it's a little arbitrary. But it depends on the market and so forth. When I tell you later, short run means this and long run means this, okay? But at any rate, obviously the long run allows for more time for consumers to substitute. So let's look at the short run first off. Let me see if I can just put that problem there. Here we go. Okay, so this is number 3 in the short run, okay? In the short run, they're telling us that the price elasticity of demand is 0.2, okay? If the price of heating oil rises from 1.8 to 2.0, we'll be able to find the percent change between these two prices as well. The first price is $1.80 a gallon. The second price, they tell us, is $2.20 a gallon, okay, per gallon. That's what they're telling us here. What happens to the quantity of heating oil? Okay, so let's, you know, we're going to use the price elasticity of demand formula, but let's go ahead and find the percent change in the price. They tell us to use the midpoint rule. Worry about that. So this is going to be percent change in the price is P2 minus P1 over the midpoint. Sometimes I just write midpoint if I think I can do it in my head, okay? But otherwise, write the formula P1 plus P2 over 2, that fraction. But at any rate, this is 220 minus $1.80. And the midpoint of those two, even I can do that, is mathematically challenged, as your professor is. I can do that. So this is 0.4 over 2.0. And so I believe that is 0.20. Okay? So this thing that's going to be in the numerator, this expression here for E sub D, price elasticity of demand being the percent change in quantity demanded over the percent change in the price. Now, this is 20% as well. So you can work with a percent or you can work with a decimal. It doesn't matter. But if you got percent in the numerator, you're going to do it in the denominator as well. But they're telling us, first off, in the short run, again, E sub D is 0.2. So I'm going to use that here. 0.2 is equal to percent change in the quantity demanded over this thing right here, 20%, 0.20. Okay? So what happens to the quantity demanded of heating oil? Just cross multiply. Percent change in quantity demanded is the product of these two. Now actually, I left the percent on here. Just have to understand really what we're working with here. This is 0.04. Really what that means is 4%. Okay, so if the price of heating oil increases from $1.80 to $2.20 a gallon, then we know right away by the law of demand that the quantity of heating oil is going to fall. But by how much? It falls by 4%. This would be a decrease. Okay? Good exam kind of question, so forth. They ask you the same thing for the long run, remember? In the long run, E sub D would be 0.7. And you do the same thing, same calculation, okay? I don't think we need to do that. Okay. Now, but when you do, and I want you to do this, okay, on your own. Might give you some, this is one I might give you time to do here. But when you do, in the long run, LR, they tell us that E sub D is 0.7. When you do that, you should get a figure that's greater than this, right? Because in the long run, you have more time to substitute. A demander has more time to substitute. Find some other way to heat their apartment. Go out and chop some wood, I guess. that might not make you your landlord's favorite tenant, but so don't put a wood burning stove in your house if the chance it'll burn your house down. Okay. I got a reminder of this last night. I sleep in the living room a lot, and man, I said, it's getting warm, and I thought I was turning the fireplace down. Got a gas, but I've turned it up. Went back, and there it was. It's like, wow, house is on fire. It seemed that way, wasn't? But anyway, okay, so that's number 3. Okay. Y'all understand why, if you got more time to substitute away from the good, then price elasticity of demand is going to be higher. Let's look at, I may be jumping around here, but I'm working these in a certain order of importance, okay? I want to make sure we get some of these concepts in. So look at number 10. So I'm going to jump to 10 here, and this is on page 110, okay? Let's see if I got this copied here. Number 10. All right. Okay. Oops. Okay. Consider public policy aimed at smoking. All right. So studies indicate that the price elasticity of demand for cigarettes is about 0.4. By the way, there's a chart in your book. I kind of should have alluded to it, but they have calculated price elasticity of demand for lots of goods. Cigarettes is on that chart, okay? So go back and look at that. We might here in a minute make sure it seems reasonable. But this is a price inelastic good, right? I mean, that's less than 1. So if a pack of cigarettes currently costs $5 and the government wants to reduce smoking by 20%, by how much should it increase the price? Okay, so by how much should it increase the price to decrease, to reduce smoking by 20%? So this sounds like an elasticity problem to me, right? So we want to reduce smoking by 20%. Let's write that mathematically. This is what we want. Number 10. In number 10, we want to achieve the following. A percent change in the quantity demanded of a negative 20% or 0.20. Okay, we want that to go down, right? And they tell us that E sub D is 0.4. So this is a price inelastic good. Okay. As far as total revenue and price goes, we could look at that question too. Is the total revenue to the cigarette industry going to go up or down when we raise the price? Okay. But at any rate, you might think on that just a bit. But so using the fact that E sub D is the percent change in the quantity demanded divided by the percent change in the price. Then first thing is, I mean, they say they currently cost $5, so we're going to find out what the new price has got to be here in a minute. But we can first find the percent change in the price, and then we could tack that on onto $5 if we have to. Okay, so E sub D, they tell us is 0.4. So let's do some substitution here. So this is 0.4 is equal to, okay, the numerator, we don't need the sign on that. Percent change in the price. Okay, does that make sense so far? Just using the definition, mathematical definition of price elasticity of demand. So let's find the percent change in the price that would be required to achieve this drop off in demand, quantity demanded of 20%. So this would be 0.20 over 0.4, just cross multiplied, right? It's 0.50. Okay, so the percent change in the price has to be 50%. Okay, this would be 50%. So there needs to be so think about this, okay? To decrease demand, quantity demanded by 20%, we're going to have to raise the price by 50%. Sound like a pretty price inelastic good, right? And well, cigarettes are that way because they're addictive. Things that are addictive in nature have a low price elasticity of demand. Okay, so we need to find, okay, what would the new price be? Okay, one way of looking at that is to note that, you know, the percent change in price is 50%. So I can write that this way. I can say the percent change in price. Remember, that's P2 minus P1 over the average of P2 plus P1 over 2. Doesn't matter what order you write that in. But, so that's the percent change in the price. And we set that equal to 0.50. And then, of course, we know one of these prices, right? We know P1. They tell you it's $5. So you're starting at $5. So P2 minus 5. Since that's $5, I mean, I could write it this way. But so P2 minus 5 over P2 plus 5 over 2 is equal to 0.50. Okay. So I just need to solve for P2, just a linear equation, right? So one way to do that is invert the divisor and multiply. I'm going to put my 0.5 here. It doesn't matter. So this is P2 minus 5 times the reciprocal of the divisor, denominator. Hopefully everybody remembers this from school. That makes sense? Okay. So what I'm going to do now is I'm going to cross multiply. So this is the only denominator over here. So I'm going to write 0.50 times P2 plus 5 is equal to 2 times P2 minus 5. So now I'm getting a nice little linear equation here with my unknown on both sides. 0.50 P2 plus, this looks to be 2.5 is equal to 2 P2 minus a 10, all right? So if I bring my P2s to one side, it's going to be 1.50 P2 is equal to 12.5. Okay, I brought my numbers to the left and P2 to the right. So P2, solve for P2 here, is 12.5 over 1.5. Anybody know what 12.5 over 1.5 is? I think it's 8.33, but Dr. J wants to check his reasoning out here today on his handy dandy TI 30 plus. Hope you can see that. So just as 12.5 over 1.5, 12.5 divided by 1.5. 8.33, okay? So that's the second price, 8.33. It's a repeating 3. Put a dollar sign in front of that. So the price of cigarettes initially is $5, okay? It's got to rise to $8.33 for the quantity demanded to be cut in half. So, I mean, we could kind of sketch that demand curve just a little bit. Okay, they're initially at $5. There's a point out here. Okay, at $5, whatever the quantity demanded is. They didn't tell us what it is, but we want to cut it in half. So we're going to have to raise, okay, the price to $8.33. Okay, so the price is going to have to increase from $5 to $8.33 so that this decrease in demand, this is the change in quantity demanded, would be half of this distance here. It's a 50% decrease, okay? So this would be a 50% decrease. 20%. 20%. You're absolutely right. 20%. Thank you. Thank you, Riley. I should give you a extra credit point. But you're right. The problem said 20%, right? So for a 20%, if I said 50% before this, because I looked over here and 50%. Yeah, it says, to what must the price increase so that the quantity demanded falls by 20%? So, you know, if there were 1 million packs of cigarettes sold this month at $5, then in the next month there'd be 800,000, which would be a 20% decrease if the price rises from 5 to 8.33. I really appreciate that. There's nothing that aggravates me more than if I watch a video and go, oh, man, I meant to say that. And I said, it's so easy to do. There's a B and C on this, I think. Let's look at parts B and C. If there's no questions on that. If the government permanently increases the price of cigarettes, will the policy have a larger effect on smoking per year, 1 year from now or 5 years from now? Okay? What do you think, class? So, now there's a reason. First off, a couple things. There's a reason why they slap all these taxes on cigarettes and alcoholic beverages, because there are all these stamps and all. You see federal excise taxes on these things because they're addictive goods, okay? So people will still pay the taxes for the most part. With cigarettes here, gosh, they increased the price here by from $5 to $8.33. And people, I mean, 80% of the demand is still there, right? That's what we see here. So actually, I could have drawn this kind of more vertical. It's a highly addictive thing. But at any rate, related to that, in the long run, what do you think would happen to the price elasticity of demand? If the government permanently slaps on taxes so that this is achieved going forward, how are demanders going to respond to that? Anything we've talked about? They're going to have more time to find substitutes, right? So if you have more time to find substitutes, what about the price elasticity of demand in the long run? Would it be higher or lower? Higher, okay. Going to be more elastic in the long run, right, than in the short run. Demand elasticity is higher in the long run than in the short run. We saw that with gasoline. You see that with lots of things. If you got to search for the substitute, you're allowed more time to do the search. Studies also find that teenagers have a higher price elasticity of demand than adults. Okay, class. Why might that be true? We just had kind of a generic E sub D there of 0.4, I think. Price elasticity of demand, we said it was 0.4. That's kind of an average. Yeah.
Because they have less money, so they're going to be more.
Okay, well, they do. That's true. They do. Exactly. That's a good one. Okay. Actually, it's probably more than one reason. That's a very good one. Young people have a smaller income, and cigarettes takes a bigger bite out of their income, right? So, I mean, we saw that with other goods. That's a very good reason, is that, you know, they're going to look at an increase in price. They're going to look at cigarettes more as a luxury, okay? That's another one. That's a good one. Is there another one maybe? That's a very good one. But in fact, that's probably maybe the best reason, but I had something else in mind. Well, older people, I think, are probably more hooked on cigarettes than younger people. I mean, if you've been smoking all your life, you know, that's a lot longer time if you're my age than if you're your age, right? So it's hard for someone like me to change a habit over a lifetime than it perhaps would be for a young person to change a habit they've established over 2 or 3 years. So again, the addictive nature of cigarettes is more profound. It's more pronounced, rather, in an older person than in a younger person. So, okay, all right. Okay, and you might think of some others. There might be some other reasons, but those would be some good ones. Okay, I want to make sure we do everything here to get you ready for the test. So I'm kind of thumbing through some stuff here. Look at number 5. Okay, we're jumping around a little bit here, trying to get you ready for the upcoming show-off opportunity, right? So, cups of coffee and donuts are complements. Both have inelastic demand. I guess I believe that. I have to have my coffee, all right? I went yesterday, did not drink a cup of coffee. The first time in a long time, and I had a headache last night. So I said, and I rarely have a headache. So I said, well, man, I'm kind of hooked on coffee. Donuts, those are addictive too, okay? So both have inelastic demand. I believe that. Donuts are cheap for the most part, kind of cheap, you know. Okay, I'll buy that. A hurricane destroys half the coffee bean crop. Use appropriately labeled diagrams to answer the following questions. Okay, so they ask a series of questions here related to the destruction of half the coffee bean crop. What happens to the price of coffee beans? Okay, I think it's pretty obvious, isn't it, that the price of coffee beans, what would it do, okay? It's going to increase, but why?
Scarcity.
Okay, yeah, so there's a supply shift, isn't there? Exactly right. Okay, so how would we draw that? Okay, well, as far as part A here goes, we just we can just draw a little supply shift. Well, fiddle. There we go. So S0 and S1, or S1 and S2, however you want to do this. Sometimes you'll see it S0 and S1. I don't know. So anyway, equilibrium price and quantity. Okay, so we see the price goes up, quantity goes down in the marketplace. Okay, so this is your standard demand curve and price. Okay, so this is how that works. Okay, so this is the market for coffee beans. And gosh, that hurricane destroyed a bunch of them. That's not too fanciful because we have hurricanes in the Caribbean a lot of times, and that can happen. Okay, what happens to the price of a cup of coffee? Okay, what do you think there, class? Okay, the price is going to increase. Right, we know this from experience. And so the reason why is because, well, we know coffee beans is an input for coffee, right? And so if you increase the price of an input on the supply side of the market, that's a decrease in supply as well. So I'm going to write this, but this is a different market, okay? Oops. This is a different market. This is not the market for coffee beans. This is the market for cups of coffee. So an input to supply will cause a left shift in the supply curve. A left shift is a decrease in supply. Not necessarily a decrease in quantity supplied, but a decrease in supply. So equilibrium price in this market here, this is a product market, is driven up. Equilibrium quantity decreases. Okay, all right, so far so good. Okay, so this is a different market than this one. This is the market for coffee beans. This is the market for cups of coffee. So they look a lot alike, okay, but they're two different markets. Okay, but now, what happens to the price of donuts? Okay, whoa, there we go. Part C, what happens to the price of donuts? And then what happens to total expenditures? And I guess they asked this here too. I skipped over it here, I'm sorry. Part D, what happens to total expenditures on cups of coffee? Okay, that's a good question. So, total expenditures. Okay, there was a price increase. What else do you put with this to determine what happens to total revenue? You got to know whether it's price elastic or inelastic. They told us that we all know coffee's inelastic. You got to have coffee. You can't live without coffee. It's one of the 4 food groups. So that's the way I look at it. So you got to have coffee to live. If I weren't awake, my wife would have to put it in my veins somehow with a syringe. You got to have coffee to live. So a very inelastic good. So my question here is, given the fact it's inelastic and there's a price increase, what happens to total revenue? Okay, it's got to increase. All right, that's exactly right. You see, again, total revenue is price times quantity, and there's an increase in price. And these two things move together for an inelastic good, price inelastic. So it's understood we're talking price inelastic. So how would you graph that? I mean, how would you graph that on here? Well, we're saying that you start with that revenue rectangle, if you will, the price times the quantities, the length times the width of that rectangle, and we're changing it to a bigger total revenue rectangle. So total revenue, total expenditures on coffee's got to go up. Wow, okay, so a hurricane comes through the Caribbean, wipes out all these coffee bean plants. What's the result? Americans are spending more on coffee, okay? All right, so I mean, the law of demand, basically, since this is sloping downward, and we know that the price has got to go up. But since Americans are hooked on coffee, they're going to spend more. They're still going to buy their coffee. Okay, now how about donuts? Okay, because they're asking here, first off, what happens to the price of donuts? Do they go up or down? And then what happens to the total expenditure on donuts? Now, they said that donuts was price inelastic. So, I mean, that's going to help us find something about total revenue. But first thing we know about donuts is you eat them with coffee. So they're complements. All right, so price of coffee goes up. This is in part C. Price of coffee increases. We've just established that. As a result, then a complement is going. The market in the market in the complement good is going to behave a certain way. What's going to happen as a result of the fact that the price of coffee increases? What's going to happen in the donut market? If you were going to graph it, what do you think, class? The complements.
Demand shift.
Demand shifts, right? There's a demand shift. Exactly right. Give this man a cigar, okay, or whatever. Okay, so demand shift. So that's exactly right. And complements is going to work this way. Here's demand, D0, and this is supply, and there's going to be a leftward shift in the demand. You can call it D1 and D2, or D0 and D1, it doesn't matter. So, look what happens here. There's some things we can say unequivocally is the price of donuts, the equilibrium price is going to go down, and the total revenue of the donut market's going to go down, or total expenditures on market's going to go down. All right, so price of donuts is going to decrease. Okay, because it's a complement. So you need to understand it actually causes a leftward shift in the demand curve in this market. So because you run up the demand curve in the coffee cup market, cups of coffee, see, we just really ran up the demand curve here. If you run up the demand for cups of coffee, that has just increased the price. You cause a leftward shift in the demand for a complement. So the price of donuts is going to decrease, and total expenditure is also going to decrease. Now, these are fairly straightforward. If you've had your coffee in the morning, you can kind of reason this out. But we know what happens in the marketplace. We say, oh, wow, look what happened to donuts. Well, don't you know what happened to coffee? We can reason that out. But what you'll have to do well on the exam is you'll have to be able to explain these different markets, how they're related, and how a little change in one market can cause a change in the other, okay? Now, if coffee a thing here to note, first off, okay. Where's my donut? Okay, here's the market for donuts. This is the market for donuts. Now, they told us that the demand for donuts is inelastic, okay? So, I mean, you got to have your donuts. So the price and total revenue have to move together. It's another thing to note here. So this also results from the fact that we're looking at an inelastic good when you're talking about donuts. If you're hooked on donuts, you got to have donuts. Now, when I was at summer camp in the 8th grade, I think it was in the 8th grade, I was at a place where they had all these glazed donuts, and I told myself, because my mom and dad just didn't let me eat whatever I wanted to, but I was away from home. So I said, I've never had all the glazed donuts I've wanted in life, And so one day I just ate glazed donuts. I just pigged out on them. And for several years after that, I could not stand the sight of a glazed donut. So my demand for glazed donuts changed. You know, and some other things of that way, I'm being a little facetious, but some of these programs to get you to stop smoking, okay, it's like they'll make you kind of like camp out in a room full of cigarettes, butts and so forth. You know, you got to smell that and so forth. You just get so much of it in your system, it kind of nauseates you. So anyway, your individual demand, price elasticity of demand can change, can be forced to change. Okay, so we worked number 10. Any questions on that? How about we back up? That's number 10. So how about number 9? I'm spending a little time on this because these are very good exam kind of questions, okay? So, 2 drivers, Thelma and Louise. That sounds like some sort of TV show. Thelma and Louise each drive up to a gas station. Before looking at the price, each places an order. Thelma says, I'd like 5 gallons of gas. Louise says, I'd like $20 worth of gas. What is each driver's price elasticity of demand? Okay. All right. So what about Thelma first? So Thelma says, you know, I want 5 gallons of gas. She doesn't even look at the price. I hate to say it, but I'm kind of like that. It's like, I pull off the road, I'm going to fill my tank up. And then my wife, I'll get back in the car and she'll say, well, how much was it? Oh, I didn't even look. Okay. So, but most people do look at the price. If it's too high, they'll drive on down the road. But no, not Thelma. So her price elasticity would have to be what, class? She's not responsive to a change in price, okay? That's a hint. So the quantity she purchased does not respond to a change in price. It could be double and she's still going to buy 5 gallons. So her price elasticity of demand is 0. So if you're just thinking about Thelma, E sub D is equal to 0. So she's going to buy the same quantity no matter what. Now, Louise says, I'd like $20 worth of gas. Okay? So with Louise, she's going to spend the same amount no matter what quantity or price it is. Okay? She's determined to spend $20. So she's like, you know, as we've seen before, whether the price is high or low, her total revenue is the same. Okay, or total expenditure, I should say. It would be the revenue for the gas station owner. But does that remind us of anything? If your total expenditure is the same at 2 different prices, okay? Okay, you have unit elasticity, okay? It doesn't go, if the price of gasoline had gone up and you know, she were going to spend more, that would be an inelastic good. Okay? E sub D would be greater or would be between 0 and 1. If the price had gone down and you know, she spent less, that would be an inelastic good as well. But if they go in opposite directions, the price had gone up and she spends less, that's a price elastic good. The thing is, there could be a change in price here and her total expenditure is unaffected. So let me write that here on my paper here. Louise, since her total expenditure is unaffected by a change in price. Can y'all read my writing here? Probably not. So since her total expenditure is unaffected by a change of price, then E sub D is equal to 1. Unit elastic, okay? If her expenditure went up in the face of an increase in price, she'd be price inelastic. If her total expenditure went down in the face of an increase in price, she'd be price elastic. Neither one of those. So she's in the middle there. She's between it being a price elastic and a price inelastic consumer of gasoline. Hope that makes sense. So E sub D is 1 for her.
So it does seem like, since neither person is looking at the price, neither of them, I'm a little confused because it seems like neither of them are responding to price at all.
Oh, okay.
But they still care more about one thing or another.
Okay, here's the deal. It's like Thelma does not respond to change in price. That's absolutely right.
Mm-hmm.
Louise, for the moment, doesn't because of where the price currently is. Okay? In other words, did they give us, they didn't tell us what the price of gasoline is, but let's just look at Louise a second. This is her demand for gasoline. And because of where the price of gasoline currently is, apparently the current price of gasoline is near the midpoint. Okay? So, you know, it could be here, it could be here. It's within a range here. The price is within a range that corresponds to that of the midpoint. And so, you know, that's the idea there. So whether you're talking this total revenue or this total revenue, they're essentially the same. Now that's what's true for Louise. So, you know, her total revenue is unaffected by whether the price is here or here. Now Thelma, she's just completely heedless about the price of gasoline. She says, just give me $20. So the price could be way up here, in which case she's not getting very many gallons, or it could be way down here. So that's kind of the difference. Does that make sense? This is for Louise. So the total expenditure is going to be within a range because the price for her is in the range. So she's actually responding a little bit, just not enough that's measurable, okay? That's the idea. It's just not measurable. Let's see here. Okay, let me give y'all a chance to work one of these. And I mentioned before class I might do this. So on number 7, okay, and we got just a few minutes left. This way I can circulate a little bit, make sure I know everybody's names and so forth. On number 7 in your text, I'll put this up here so you can see it. We've worked, I think last time, 3 of these. We've worked almost all these problems now. But I'm going to give you a couple other prices, see if you can do this, okay? So this is pizzas. Remember, demand schedule for pizzas in a town at 2 different incomes, okay? So there were 2 things they asked us. Use the midpoint method to calculate the price elasticity of demand as the price of pizza increases. Okay, so what I want you to do, I'll put this in a box here. Find E sub D between these 2 prices. Okay, so A part here, just for a class exercise. Find E sub D when the price increases from $12 to $14, okay, for an income of $24,000. Okay, so I'll give you 5 minutes on that. Can y'all give that a whirl? Okay. Find E sub D. And then I may have you do an income elasticity, but let's see how this goes for you, okay? So I told Miss Emma back there, our technician, she's so great. I told her that I was going to do this today. While you are working on this, Dr. J's a slow learner, but he's going to circulate and make sure I know. And I lost my role where I had your seat assignments, okay? So we got 5 minutes. Okay, can y'all work that? Tell me what you get, all right? See if you can work that. You got 5 minutes, okay? Back when I was in school, you did this all the time. So, but you had to turn it in. I won't make you turn it in. Now Noah's here, so I got Noah here. Noah, I know. And let me know if you got a question, okay? So this is first row, middle. All right. And Riley is here. Riley's here. O'Reilly Auto Parts is here. I was having to make. Remind me your name. I'm sorry.
Seth.
Seth. You are Seth. Okay, now that I should remember because my grandson's name is Seth. Okay, yeah, it's a great name. 1L. Okay, gotcha. Thank you, Seth. Tell me yours again. Brianna. That's almost like Brian, my name. Okay, Brianna. See, Brianna Matus.
My grandpa's name is Brian.
Oh, is that right? So you're named after your grandpa? Okay. Well, he's got a beautiful name. All right. And my lady from Dewey, and you, don't tell me, Taylor. Taylor, I know. Taylor. So how are the roads between here and Dewey today?
Coming off of doing some due to Barksville, they're still kind of icy.
Oh, are they really? Yeah.
Most of the back roads are.
So,
Highway
okay.
75's clear though.
Oh, is it? Yeah. So do you know where Tuxedo Boulevard is? So when we lived in Bartlesville, we lived right off of East Tuxedo, pretty close to that park. I forget the name. There's a park on the east side of Bartlesville. Sooner Park, I think's the name of it.
Yeah, I know where Sugar. I don't live there.
Yeah. Oh, really? Yeah.
I live more closer to Copan.
Oh, okay. Yeah.
So
I like
I'm not
that.
too far from it.
Oh, okay. I like that lake there, Lake Copan. All right. Yeah. Remind me your name here.
Jesse Choplin.
Jesse Choplin. Okay. This is 1, 2, 3. Okay, Jesse Choplin. Okay, sorry I forget. And this is, don't tell me, because I can figure it out. This is Finn.
That is good.
Finn Osborne. Okay. I don't meet a Finn every day. Maybe that's why. Okay, 3M. Okay. There was something you emailed. I took care of you. Oh, yeah. Okay, you good on that? Did you see my email?
Yeah. That's wonderful. Yeah.
Yeah, I sent you an email last night, I think. Let's see. I know, I should know. Oh, let me start up here. Nasir. All right. Nasir. This is 2 right. Okay, and I should know. It's either Lee or Ryan. Ryan? Lee. I'm sorry.
He's my middle name, but.
Oh, okay, yeah. Aaron, Jordan. Jordan's back there. I'll remember that, Jordan. Don't know why I know a few Jordans. 1, 2, 3, 4, 5. 5 are. Okay. All right. I know James. No, okay. Deacon. No, Deacon said. Okay. Ryan, Luke, Johnson. No, Luke. No. Okay, tell me.
Steven.
Well, I don't see that here. Oh, yeah, here it is. Okay, Stephen, I got it. Okay, I'm sorry. I should not. I should just. There's a smarter way to do this where I wouldn't reveal my. Okay, I got it though. It's implanted. Do what?
Look for the guy in the hat.
Yeah, the guy in the hat. I'm writing here Ariad. I'm sorry, Ariad hat. The guy in the hat. I got some Ariad shirts I really like. Okay. They're not, are they? My wife bought them for me. I said, "You spent what?" Remind me your name. Luke. Yeah. We've talked before too. I'm sorry. Luke. Okay. Looks like we're almost out of time. All right, I guess we're